Hello and welcome to instruction video number 4 for the Superjig 2.0. This is the final video that I had planned, but you never know, there might be another one in the future. In this video I will show you how to cut tenons on this jig. I will cut normal standard tenons, double tenons, and I will also show you how to cut angled tenons. I have intentionally placed this tenon video as the last of the instruction videos. Not that the tenons are more complicated than other joints on this jig, but there is a significant difference. Up until this point, whether we cut standard box joints or variation box joints or bridle joints, the fit between the parts have been controlled within the jig itself, since both parts have been done on the jig. And even if you see my caliper every now and then in the videos, after we figured out the blade curve, we actually haven't needed to measure anything to get a perfect fit between our parts. The obvious difference is that for a tenon that should fit a mortise, only one of the parts is done on the jig, and that's the tenon part. That part we can control very well on the jig, but the mortise is not done on the jig, so that one we can't control. So this video will be much about fitting a tenon to mortise, and there will be slightly more measuring involved than in the other videos. Just as for the bridle joints, also for the tenons, you're free to choose finger or tenon thickness in steps of 0.05 millimeters. And once familiar with your blade curves, which we are now, the most likely result is that you get a perfect fit on the first try without any need for test cuts. And if you need to adjust the dimensions, just as for the other joints we done on this jig, you can do that in steps of 0.05 millimeters. There is a slight difference from the other joints cut on this jig. When I cut my tenon joints, I only make these cuts on the jig, and then I clean up the shoulders afterwards on my crosscut sled. Before cutting any tenons, I need some mortises to fit them to, and I use my router mortise jig for this. This jig has its own video. This is just a quick overview of how it's done. Then I clean up the corners using a chisel so I get nice and square corners in my mortises. So there we have some mortises of various types for today's video. The first tenon of today is a standard single tenon that will fit this mortise here, and I will make this tenon so that the outside surfaces of my parts are aligned on one side after I assemble them. This is a typical situation if you're aiming for flush cut joinery with no steps on the outsides. This tenon will be slightly off center and the left side cheek will be smaller than the right one, but on this jig it really doesn't matter. Making an off center tenon like this is just as simple as making a centered one. I do as usual, I sketch up the joint to set the pin positions, and for that I use the standard rule that we use now in all the videos. For single tenons like this I actually have a shortcut method, but I will show that last in this video. Until then we stick with the standard rule. I made a very basic sketch for this tenon, and as usual the 0 on the left side. Then I go ahead and measure my mortise dimensions. So the left side is about 10.2 millimeters. And the mortise itself is about 15.3. So for this position I end up with 10.2 plus 15.3, that's 25.5. Then we use the standard rule. We start our cut at the number, that's 0, and we end that cut at the number minus the curve. 10.2 minus 3.25, that's 695. Then we start the next cut at the number 25.5. As mentioned, when cutting tenons, I only make this cut here and this cut here. I don't cut away the remaining waste on the sides. So the 0 will actually not be a real pin where I make a cut, so I put the parenthesis around that one, and then in 695 I put the green pin, and in 25.5 I put the red pin. Then a quick recap from video number 1, where we figured out that 3.25 curve gave us a nice fit for the box joints, where the cutouts were around 11.05 and the pins were around 10.95. If we apply that here using a curve of 3.25, we should end up with a tenon slightly thinner than the 15.3. It should be around 15.25. As usual, the tenon dimension can be adjusted in steps of 0.05 millimeters, moving the stop pin. But I will start with these pin positions. They should give us a nice fit between the tenon and the mortise. I head over to the jig and set it up for the cut. Here I set the blade height to be just below the layout line, as I later will cut the shoulders on the crosscut sled. Then procedure as usual, I move the carriage to align the left side of my workpiece with the left side of the blade. If you really want to nail down this dimension, you can do the zeroing operation described in video 2. Here I zero the system using a temporary pin. I will not cut anything in this position, and this pin will later be removed. Green pin at 6.95, so here we are at 4 and then another 2.95. Red pin 25.5, next time we pass the 0 we are at 8, that makes it 12, 16, 20, 24 and another 1.5, red pin. Now I don't need this temporary pin anymore, so I remove that to not confuse me when I make my cuts. I also line the 0 on the scale ring with a green pin. I will write down my pin positions on the template, and it's always nice to have the green pin in the 0. This means that the red pin ends up in 2.55 hole. As usual, I go ahead and mark my template with the joint type, the blade type and the pin positions. So next time if I'm making a tenon for this mortise I cut with this router bit, the setup time is under a minute. You could also cut the 2 remaining sides using the jig if you rotate the workpiece 90 degrees. But usually the accuracy requirement on those sides are not very high, and then I just use the bandsaw for this since it's a quicker method. When cutting the shoulders on a crosscut sled like I did here, you have the blade a little bit low, and that is to not cut into the tenon itself. And this leaves a small rest here, as you can see in this inner corner. This is easily cleaned away with a chisel. To me this tenon looks really good, it's crisp and nice, and there are no steps anywhere between the shoulder lines. I put a small chamfer on all the top edges of the tenon, and that is to allow easier insertion. Then it's time to measure it and do a fitting test. So we aimed around 15.25, let's see where we are. That's close enough. Dimensions is one thing and that's nice to have, but the real important test is the fitting test between the parts. Slides in very nicely, it's not too snug and not too loose. There are no visible gaps on any side of the joint, and the outsides are well aligned. That's how you work with this jig when you have confidence and experience in your blade curves. It is actually this good and there is no staging involved in this. But if you don't have that experience, you wouldn't take it to complete tenon before you're making the fitting test. You do a quick and dirty tenon on a piece of scrap and try it out, and then you adjust your pin positions for a perfect fit. Next up is a double tenon to fit this double mortise. This will be very similar to what we just did, so we skip a few steps here and there. The tenon piece will fit the mortise piece like this, and it will stick out around 7 millimeters on each side. We do it the usual way. I sketched up the joint, and then as I mentioned I have 7 millimeters outside the first tenon, so that position is already set. And then I go ahead and measure my mortises. And the first one is 10.1 millimeter, and then I have a distance between them 9.9. Then I have a second mortise, also that 10.1. 10.1, 9.9, 10.1, and then I use this to calculate my cut positions. 17.1, 27, 37.1. Same procedure as every time. Start my cuts at the number, end them at the number minus the curve. Here I will begin with one cut here, then I will cut here and between the tenons, and then I will finish with a cut on the right side. So just as for the single tenon, I won't make any cut in the 0 position. the first pin will be the green one at 375, then 17.1 will have a red pin, 2375 blue pin, and the final one will have a black pin. Here I see one thing already now, maybe you don't see it, but you will see it when we set the pins in the control wheel. I have set the blade height and zeroed the system using a temporary pin, just as I did for the single tenon. Then the green pin should be at 3.75. Red pin 17.1, we are at 4, 8, 12, 16 and another 1.1. Red pin. Blue pin 2375, we are at 17.1, that makes it 20 and then another 3.75, but there we already have the green pin. And this is what I saw coming already when I calculated the pin positions, and with some experience you will learn to see this quickly as well. But this is not a problem, we can use the green pin again, so I just skipped the blue pin. Final pin, the black one at 37.1, we are at 24. 28, 32, 36 and then another 1.1, and there we already have the red pin. And the same goes here, no problem to use the red pin again, so I place a red line on the template and I skip the black pin. I finished my template by hatching the area between these two lines, as here I will remove material. This template, it's very unlikely I will save for the future, so I don't bother to write down the blade type and the pin positions and this kind of information. I cleaned up the shoulders on the crosscut sled just as for the single tenon, and when you do this on a double tenon it will leave a small step or rest between the tenons. Either you chisel this away on the tenon part, or when you route the mortise you make a shallow pass between the mortises to make room for this step. I used a chisel to remove this small step between the tenons, then I chamfered the top edges. That makes this double tenon complete. Then it's time for the compulsory fitting test. It slides in quite nicely. Just as the single tenon, it's a well-seated joint without any gaps on any side. I think it's time for a small disclaimer, so you don't think I work like this and measure every mortise with a caliper and custom fit every tenon to every mortise. Now this is partly show off to show the accuracy in the system. If I would do this real world, I would measure a few mortises and they should stay quite consistent, and then I would cut all the tenons to the same size. It's time for the final joint of today, an angled tenon, and here I will show you an alternative method for setting the pin positions for single tenons. This angled tenon should fit this mortise here, and that mortise is the same size as the one we started out with, this one here. Here is the single tenon special rule, and with this method I only care about two positions, this one here and this one here. I don't care about what's happening over here, and this is especially useful for an angled tenon where I would have problem to find the zero position out here. With this method I use layout lines on my first workpiece to be able to make the template. Then I start by aligning the saw blade with the left side cheek of the tenon. Here I zero the system and I make the first cut at 0. Then the second cut position is this one here. Second cut at tenon thickness plus the kerf, 15.3 plus the kerf, that's 18.55. And then business as usual, 0 gets a green pin, 18.55 a red pin. As beginners with this jig system, I recommend you use this special rule only for single tenons in the beginning, and you use the standard rule for everything else. Then as you get more experience, you will learn when there is an advantage to use the special rule. I will now prepare the workpiece and then set up the jig for the cut. I start by setting my saw blade to an angle, then I cross cut my workpiece. Then I lay out my tenon, and for an angled tenon there is no smart way to cut the shoulders afterwards on the crosscut sled, so here I need to cut away all of the hatched areas on the jig. For cutting an angled tenon you could work with these custom wedge shapes, just as I described for cutting an angled bridle joint. Then you cut this to the same angle as the joint that you want to cut, then you attach this to the flange using double-sided adhesive, and then you clamp your workpiece on the outside of the wedge shape. But if you're into angled joinery, I really recommend that you make this tiltable flange instead. It's a super simple conversion of the jig. Then you just tilt the flange to the same angle that you had on the saw blade when you made a crosscut, and then you lock it in that position. For a tenon, it's not crucial to have tear-out support on the part of the tenon that later will be inside the mortise. So although on angle cut, you can have normal support pieces. You don't have to cut this to an angle as we did for the angle bridle joint. With layout lines on my workpiece, I begin by aligning the saw blade with the left side layout line. Then I do as usual, I put the green pin in the hole that matches the reference line on the jig, and I zero the scale ring. Red pin 1855, 4, 8, 12, 16 and another 2.55. There we place the red pin. 2.55 for the red pin is the same position as we got when we used the standard rule. So there is no magic about this special rule, it's just another way of calculating the pin positions. If you have problems to set the blade height for an angle cut like this, you can use the waist area on either side of the tenon and then sneak up on a perfect height setting. After I raise the blade in small increments, I'm satisfied with the height setting and it's time to cut this tenon. Since I can't cut the shoulder lines on the crosscut sled for this angle tenon, there is slightly more manual work involved in cutting the last two sides. Angle tenon complete. The shoulder lines looks crisp and sharp without any obvious steps. It's time for the final fitting test of today. Slides in quite nicely, and as far as I can tell, it's a well-seated joint on all four sides. We have reached the end of this presentation and the end of the instruction videos that were planned for now. I will figure out what to do with this mounting of sample joints, and then I will continue with my ordinary woodworking life. This is a Superjig and it's well worth the time it takes to build it, and I hope that you enjoyed watching this. Thank you very much.